Mechanical hard drives are among one of the most important technologies that we use in our day-to-day lives. Being the predominant form of data storage due to its density and low cost, the hard drive as an object is one of the most ubiquitous items in the home, used in computer assemblies or portable computers. While currently they are being phased out by newer and faster solid-state drives, hard drives remain as one of the most important components to modern computing. Hard drives are also one of the most visible examples of the application of magnetism in our day-to-day lives, relying on magnetism for various core operations for its functions. The hard drive is an evolution of this, a magnetic tape, just like the ones used in cassettes, VHSs, and the like. More specifically, they're an evolution of these. Yep, those things. A huge spool of magnetic tape, which is used to store massive amounts of data, even to this day. A magnetic tape drive works with a line of tape and a magnetic head, with the head being able to detect the magnetism of the region of tape, and also being able to change the polarity of the magnetism on that region of tape. Since there are two possible states of a particular region of tape to be magnetized, either north or south to the perspective of the tape head, it is possible to represent binary information using the changing state of magnetism on the tape. Well, how does it read? The tape head can detect the polarity of the region of tape by the difference in the current output from the head itself. The head often consists of a magnetic core with a small gap, and in the gap is a diamagnetic material, such as gold. A wire is coiled around the core. When the tape head encounters a piece of magnetic tape, due to the diamagnetic material repelling the magnetic flux enters the core of the head, and the coiled wire around it causes a current to be induced, producing a measurable signal which denotes the polarity of that region of tape. The head design is also often reversible, meaning that it can use the same principle backwards in order to change the polarity of the tape. A current being put through the tape head will result in a magnetic flux affecting the region of tape under the head, changing the polarity of the tape in that region. So then, if one were to take the surface of the tape and spool it into a spiral which forms a disc, you'll end up getting something similar to the surface of a hard drive platter. Though instead of being made of a magnetic coating, often of iron particles, around a plastic core like a magnetic tape, a hard drive instead is made of a coating of a cobalt-based alloy magnetic substrate around an aluminum or glass core. The heads, therefore, are placed like a needle on a record player, able to reach the entire surface of the disc as the disc is rotated around. These platters are often stacked on top of each other, alongside with more heads in order to increase the density of the data stored in the hard drive and to allow more speed and storage in accessing data. The movement of the head of the hard drive also relies on principles of magnetism in order to precisely move it from point to point. The reading and writing head of a hard drive are placed on an arm, controlled by a motor known as an actuator. On the arm is a permanent neodymium magnet, and below it is a tightly wound coil of wire. When the electricity is applied to the coil, the current forms a magnetic field, which causes a force to be applied onto the arm, causing it to be moved. The amount of current applied to the coil can be precisely controlled, allowing the arm to be moved very precisely to all locations on the hard drive platter. Over the years, the density of data that has been able to be stored on a hard drive has increased exponentially as the technology of manipulating the magnetism on the hard drive platter and the precision of the position of the hard drive head has improved over the years. While hard drives may not be as popular as they once were, hard drives are still one of the most important applications of magnetism in our day-to-day lives.